union, intersection, and the complement of events. So we are going back to basic set theory, because we shall use the notion of sets to illustrate events and to help us compute for the probability of events. You know what Venn diagrams are. Okay, so a Venn diagram is like a set of polygons and circles. Okay, we put them together like this, and we are illustrating sets and operations of sets with the help of a Venn diagram. Okay, suppose our experiment is about drawing a card from a deck of 52 cards. A, or set A, is the event when an ace card is drawn. B is the event when a red card is drawn. Okay, so I'm using here the sets A and set B. Okay, so how do we interpret A union B? How do you put that in words? Okay, so A union B is the event when either an ace card or a red card is drawn from a deck of 52 cards. Okay? How about this? A intersection B. So in this Venn diagram, A intersection B is this region. So how do you describe it in words? A intersection B. So A intersection B is the event when an ace card that is red is the one that is selected. Okay, so it is the event when a red ace card is selected. How about this? So this is the complement of A union B. So how do you describe it in words? So the complement of A union B is the event when the card that is drawn is neither an ace card nor a red card. It's neither an ace card nor a red card. And the complement of A union B is equal to, or is the same as, the complement of A intersection the complement of B. I think you are familiar with this, okay? Students who are into computer programming, basic programming, they study basic set operations, okay? How about this? How do you interpret this? It is the complement of A intersection B. So it is the event when the card that is drawn is not a red ace card. Okay? That is how you interpret that. And I think they call this De Morgan's law. Okay, De Morgan's law. These two identities here, you call them part of the De Morgan's law. So the complement of A intersection B is the same as the complement of A union the complement of B. Addition rule for sets. Given two sets A and B, the number of elements in A union B, which is denoted by this symbol, is given by this. The number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in their intersection. So some students are sometimes lost about this part. They understand this part. Okay, you add the elements of both sets, but why this? Why this? Okay, you will see it from my example. So let's say this is my set A. It contains the elements 0, 1, 2, and 4. Set B contains these elements 0, 3, and 5. So what is A union B? A union B is this one. So we don't repeat the listing of elements, by the way. Okay, so that is how you write the elements of a set. You don't repeat the listing of elements in a set. And so the number of elements in the union is 6. 1, 2, 3, 4, 5, and 6. So let us show that this agrees, or this will agree with the result of our sets, of our set operations. So the number of elements in A is 4. The number of elements in set B is 3. Okay. If the number of elements in A union B is just n of A plus n of B, it's going to be 7. And you know that it is not 7, it is only 6. So what happens here is, if we don't remove this, we are counting 0 twice. Okay? You will count 0 only one time. Okay? So the number of elements in A union B is equal to 4 plus 3 minus 1, which is equal to 6. And so the reason why I'm bringing up this notions of the number of elements in a set is because that is how we compute for probability. Okay? I hope that you can still recall how we are computing probabilities of events. Again, this is our experiment. Okay? We shall draw a card from a deck of 52 cards. What is the probability that the card that is drawn is an ace card? So using our law for computing probability, how frequently does an ace card, that is the meaning of n of A, how frequently is an ace card observed in the sample space? So that is just the same as saying, how many ace cards do you have in a deck of 52 cards? You have 4. Okay? So it's going to be 4 divided by the size of the sample space, which is 52. So the probability of getting an ace card is 1 over 13. I just canceled common factor. Okay, 4 is a common factor. What is the probability that the card that is selected is a red card? Again, n of B divided by capital N. How many red cards do you have in a deck of 52 cards? It's 26. So 26 divided by the size of the sample space, 26 divided by 52, that is 1/2. How about this? Okay, I will select a card. What is the probability that the card that I selected is either an ace card or a red card? And this is how we compute for that. How many elements do you have in A union B? Divided by the size of the sample space. How many aces are there in a deck of 52 cards? You have 4. How many red cards do you have? It's 26. How many red cards that is an ace are there in a deck of 52 cards? You have 2 red ace cards. So minus 2. 4 plus 26 minus 2 is equal to 20. So that is the number of elements in this event, A union B. So the probability of A union B is equal to 20 divided by 52. Cancel common factors. 4 is a common factor, okay? So it's going to be 5 over 13. How about this? Well, how do you interpret A intersection B? A intersection B is the event when the card that is drawn is an ace card and a red card. Okay? It is a red ace card. And we have 2 of them. The ace of diamonds and the ace of hearts. Okay? So 2 over 52 or 1 over 26. Probability of union or intersection of events. Again, we are working on the same experiment. Find this. How do you interpret that? The probability that the card that you selected is not an ace card. That is how you interpret this. Not A. It's not an ace card. What you can do is you can just remove the 4 aces from 52. So that's going to be 48 over 52. Or we can do it this way. It's equal to 1 minus the probability of A. I spoke about this from our last video. The probability of the complement of an event. And it is equal to 1 over 4 over 52. Where did 4 over 52 come from? It is the probability of selecting an ace card. Okay? So 1 over 4 over 52 is 48 over 52. Again, cancel common factors. 4 is a common factor, so it's going to be 12 over 13. That is the probability that the card that is selected is not an ace card. Okay, so how do you interpret this event? This is the event when the card that is selected is not an ace card, but it is a red card. It is not an ace card, but it is a red card. So how many red cards do you have? You have 26. So you will remove two aces, red aces. So it's going to be 24 over 52. Okay, so that is our expected answer here. Okay, so how do you compute this? First, how many events are there, or how often do you see this? It's not an ace card, but it is a red card. Okay, we have 24. Okay, we have 26 red cards in all, and then you will remove the 2 aces from 26. So it becomes 24. Okay, so 24 divided by 52. Again, cancel common factors. 4 is a common factor. 4 times 6 is 24. 4 times 13 is 52. So 4 divided by 4 is 1. We are left with 6 over 13. How about this? This should be letter G. How do you interpret this? This is the event when the card that you selected is neither an ace card nor a red card. And what is the probability of that? That is equal to this. 1 minus the probability of A union B. We already computed for the probability of A union B. It's equal to 5 over 13. And so this is equal to the probability that the card that is selected is neither a red card nor an ace card is equal to 1 minus 5 over 13 or 8 over 13.